everybody. My name is Milecia McGregor, and I'm a developer advocate at Conducto. So, today I'm going to talk to you about reading your thoughts with JavaScript. It's crazy, but we're actually at that point. And if you're interested in keeping up with me and the different projects I work on in this space, you should definitely follow me at Flipped Coding on Twitter. And if you're having problems with your CI/CD pipelines because you're tired of YAML, you should definitely follow Conducto on Twitter at Conducto Tech. So I'm gonna go ahead and get things kicked off with an overview. And we're gonna do a quick background on some neurology. I'm not a neuroscientist, so don't worry, we're not gonna get too crazy. And then we'll go over a little background on EEG signals. Then we'll go over a little more background stuff on machine learning, neural networks in particular. Then we'll get into how we map EEG signals. And then we'll talk about how you combine EEG signals and machine learning. And the part that you guys are all waiting for, which is why I have all these crazy wires on my head, is the live demo, which I checked it literally seconds before I started. So hopefully nothing broke in between now and pushing the play button. And then we'll go over a few practical uses of this after the demo, and we'll just wrap up with some key takeaways. So jumping right into it, a little background on neurology. So this is a branch of medicine that deals with your nerves and your nervous system and a lot of other brain stuff that I personally don't understand. So most of the things we'll be talking about happen in your frontal and temporal lobe. So your frontal lobe is where a lot of your rational decision making comes from. And your temporal lobe is where you get a lot of your motor skills and whatnot. So disclaimer, not a neuroscientist. So if that's a little bit off, I do apologize, but I did my research before. So right now, neurology is just having all kinds of breakthroughs in society. So there have been some paralyzed patients that have been able to shop and text just with different neurotech devices. There are brain-controlled robotic limbs, which are really cool. And there's actually been one case where multiple people played a game with just their thoughts. And that kind of inspired me to try to make something else in this space. So there's definitely going to be a lot of neurotech talk in the future. I'm sure you guys have maybe at least heard of the thing Elon Musk is trying to make, the Neuralink. So it's definitely something that's simmering in the background. But a few things we will be able to do with it include advanced exoskeletons. So you'll be able to strap into a robot suit and move it around like it's your own body. We'll have communication via thought, so telepathy is coming for you guys. And there is a chance we'll have brain implants to improve cognitive capabilities, which is a little bit wild, and we'll get into some ethical things around that a little later. So, a little bit about EEG signals. That stands for electroencephalograph signals. And basically, it just takes different electrical impulses that it picks up in your brain and maps them to different channels so that you can record that data. But the primary brain waves that we'll be looking at today are the alpha wave, which it is responsible for things like memory, a little bit of your mental coordination is involved, things like that. Theta waves have a lot more to do with dreams and definitely a lot more to do with memories, but it's more of a background type waves. And then we have delta waves, which pretty much only happen when you're in that really deep dreamless sleep, that really good sleep at night. And beta waves are the ones we're really the most interested in because these are your waking thoughts. So when you're making decisions or you're trying to solve a problem, your beta activity is really, really high. And then this is just a map of some of the points where we put electrodes for these EEG signals. And the ones that we'll be focusing on today are these two. So FP1 and FP2. And I have two behind my ears. You can see the little dot. And there's one on each side, and those are the T9 and T10 electrode positions. And then I have these on my ears just as like a ground for everything. So there are a few different ways you can interpret signals. So you have the time series where you just see the activity over time. And then for the more mathematically inclined or engineering inclined of you, we do have fast Fourier transform plots. But one of my favorite ways is just a visual. So the other two ways we talked about are great for recording information, and we'll actually be using time series information in the demo. But this is just a way where you can see which parts of your brain are really active. So at this point in time, I guess I was just thinking really hard on this side of my brain, and the rest of it is kind of darker. So it's just a way to visually see where some activity is happening. And if you are trying to, I guess, really understand particular brain waves, there are other apps you can use. So this one shows you that you're focused because your beta activity is low and your alpha activity is high. So we all know that beta waves are associated with active thoughts. So that problem solving, that decision making activity that happens in the beta frequency. So when your beta waves are low and your alpha waves are high, that typically means you're pretty focused on something. So I don't know what it was, but apparently I focused for more than 2 seconds. And now, just to switch gears a little bit, we'll do a little background on machine learning. So we'll be using a neural network for this particular model. And a neural network is just made of nodes. And a node is just a building block. So you have a certain number of inputs that you want to use to make an accurate output estimate. So what you're trying to do is take all of your input data, train a model with it, and get an accurate prediction for a value you want to know. And how this works is each input feature that you give to the model will have a certain weight assigned to it that tells the model about how important it is to the overall outcome. But inside of this neural network, it's making its own connections and giving different weights to just the other things that it formulates with the data. So it goes through all of these calculations, changing weights, and it gives you your predicted value. And this is the foundation of how deep learning works. All deep learning is a neural network with more than one node. So if you have two nodes in your neural network, you're doing deep learning. So really, all machine learning is just some programming that runs a lot of calculations on really large data sets. That's the power in it. You can take millions of data points, train a model, and accurately get predictions for different values. So using the normal housing model prediction thing, if you had millions of data points for houses all over the world, you could probably accurately predict the cost of a house in your particular city or country. So now we'll talk about mapping EEG signals in a way that's really useful in a machine learning application. So what you really want to do is try to focus on one thought at a time and record the frequencies that represent that state of thought. So that takes a lot of trial and error just to figure out what the different signals mean in their various combinations. But once you have seen enough of the data, you start to kind of make correlations enough where you can make an educated guess. So it does take some best guesses to get started because there's not a lot of open source EEG data. So a lot of it will include reading through textbooks and even trying to get your own like EEG system so you can have access to that data. But one really important thing once you get the EEG signals and you know how you want to map them, you have to clean noise from those signals. So our brains have a lot of background activity, and I'm pretty sure you know because our thoughts wander so many times during the day. And even while you're really focused on a thought, there's just noise that comes from these electrodes trying to get through your skull, basically. So you want to make sure that you can clean the noise from your signals. And then probably the hardest part is to get enough data to actually map frequencies to a thought to get a large enough data set to train with. So it took me probably 20 hours to get 4 or 5 really good data points. Not the whole data set, but just a few data points. So that's something else that comes up when you're trying to map these EEG signals to a useful thought. And then you're going to take whatever data set you build, and this is what you're going to use to train your machine learning model. So all of those raw thought frequencies that you've generated, you know which channels are connected to which parts of your brain. So after doing some of that neurology research, you'll have a better idea of how to choose features to map to your output. And then this is a question that comes up in machine learning a lot. So what's the best algorithm to use? And that really depends on what your problem is. If you're doing something like this, I personally chose to go with a convolutional neural network just to get all of the nuances that happen in these EEG signals. But you can experiment with all the different kinds of algorithms. Another one I considered was using an SVM for this kind of model. And then this is my favorite part, getting to talk about Brain.js. So the reason I chose Brain.js is because this is actually going to be used on a web app, which is pretty awesome. And basically what it does is take the processed EEG data and it creates its own neural network model to filter those thoughts down into directions on a web page. So the demo app that I'll show you will basically let you scroll a page with just your thoughts. And it doesn't sound like that big of a deal, but it's really cool. You can just move a browser page by thinking about it. So Brain.js lets us do that really easily because if you know how to work with JavaScript arrays and objects and methods, that's pretty much all you need to do machine learning with this particular JavaScript library. So something else we're going to do is use our model to predict the thoughts based on our input. So this is going to be running and reading my thoughts in real time, trying to predict whether or not I'm trying to scroll up or down the page or go left or right. And now it's the time for the demo. So I'll just give you a quick overview of the code. So this is actually what I'm running to get the data from here. I couldn't quite do that with just JavaScript, so I had to run a Python app that processes the data in real time and filters it and cleans it up. But after that, that cleaned up data gets filtered down to just alpha, beta, theta, and delta waves. And we send that information to our Brain.js model. And this is where the code really starts to come in. So if you've ever worked with Node, we just go through and set up a regular Node application, like starting our Express app, setting some ports. Then we get to our input data. So we're officially about to use the Brain.js library for machine learning in JavaScript. And all we're doing here is taking a data set that I've generated previously that has the alpha, beta, gamma, and delta brainwave signals really cleaned up. So these values correspond to whether you're thinking of up or down or left or right. And what we do with this data is combine it to make our training set for our machine learning model. And all this is, it's just an array of objects. So we have an input object and an input value, and we have an output value in our arrays. Then this is probably the best part. So this one line right here is our entire neural network. This is how you build a neural network in Brain.js. It's just one function call where you define a few different properties. In this case, I've decided to go with 3 hidden layers to give the neural network just a little bit of time to come up with some of its own connections between the data. But that's not necessary. And if you want, you can increase this number just to see how it works, if it changes the accuracy or not. Then down here is probably the second best part. So this is where we actually train the model we just made with our data set. That is all you have to do to use machine learning in JavaScript, and that's so awesome to me. So now we have our neural network trained, and we have these stats that print to the console just so we see like how many iterations it took, the error margin, things like that. And we also do a quick run of just test values to see what kind of prediction we get. And then at the very end, of course, we run the app. So what we're doing, like the main part where this gets to the front end application, is we have this very small API where we get the data that's streaming from the EEG, and then we use the values that the EEG model returns to get a predicted direction for the scroll on the web page just based off of our thought frequencies. And then we just send that value to the front end. So now that you know how the back end works, I'm going to go ahead and start it. There's really nothing that spectacular to show you here. But if you see, we have our predicted values. So based on these inputs for alpha, gamma, beta, and delta waves, we see this is likely to be a down direction thought because down dominates over the other values. So now we have our backend API running. We have the brain API running. All we need to do is go through the front end. And this is just a really simple React app. It's nothing super fancy, but the part you're probably interested in is right here. So all this is a function that calls our API that sends us the predictive value for the scroll. And what we'll do is take that response, and if we see that there's a value for up and down, which usually there will be, then we see which one of these values has the higher probability of being the direction that the user wants to scroll, and then we'll scroll in that direction for about 2 seconds. And then we'll call this function again, which will call that API, which will call the EEG API, and get that value every 2 seconds just to scroll on our tiny homepage. So homepage really isn't anything special. It's just not special at all. So I'll go ahead and run the homepage so that we can see this in action. Should be popping up here. There we go. So I have everything started up, and it should be loading any second now. Oh, I know. Oh, there it is. Just a little slow. So now it's going to start triggering that every 2 seconds. And just to show you what this looks like, I'm going to have to stop talking so that I can actually focus on a thought, which is really hard to do even on camera, like in my house. So watch the screen. Okay, so I know it looks like I did absolutely nothing right there, but that's the point. I was able to do that little bit of scrolling with just some thoughts. So, one thing you do have to keep in mind with a model like this is that a data set for one person might not necessarily work for someone else. So, my EEG data probably wouldn't work for you because our brains are just different. That's something that you have to keep in mind with a type of problem this personalized. But now that you've seen this demo, where I've improved it since I actually just fixed this like right before this, where I don't even need the blinks. Machine learning is pretty cool. Like the Python libraries have just made some changes that made it easier to process the data. And I made those literally right before I started recording this. So you don't even need to blink anymore. But if you are just starting out, blinks are a really good signal because you can clearly see them in the EEG data, but you don't necessarily need them depending on how you train your model. So I completely changed how I trained my model before the talk. You know, sometimes the best breakthroughs happen at really random times. But there are way more practical uses for something this crazy. So, we know there are a lot of people that have different disabilities that limit what they can do with and interact within the world. And technology like this can really help give people a better quality of life. So imagine if you were able to go for a drive with just your mind, like you control the gas, the brakes, and the steering wheel with just your thoughts. That would open up so much access for so many people, and that's just one of the ways we could. Of course, there's prosthetics, there's assisted learning devices for people with different like learning disabilities and things like that. So it's really easy to use this to make custom devices, custom websites, custom software. Anything can be super customized when you know exactly what your user is thinking. And then there's other ways we haven't even thought of yet where neurotech can take us to the next level as humanity, honestly. Just imagine if you were in an ER and your doctor needs something, but he can't quite think of the word for it. But his assistant could hear his thoughts and get a better idea of what tool he's looking for. So things like that will take some creativity and some time once we get the hardware really up to par. But I do want to take a second and talk about how important ethics are. When you're dealing with people's sensitive data, like their actual literal thoughts, you really want to make sure that this data is being used to help people. This isn't just to make brain streamed ads or to do other just unethical things. Make sure when you have data this sensitive that you're doing as much as you can to protect it, because this is literally people's thoughts. Like, you don't get too much more personal than knowing how to break down someone's thought pattern. Make sure that anything you do in this field is ethically sound, because if it isn't, that leads to so many other problems, and we really don't want data breaches with brain data. So, just a few takeaways. Always try to find uncommon ways to implement machine learning and other tech tools. It doesn't always have to be some ridiculous hard tech problem like logistics or image processing. It could be something else like trying to make an air guitar, which is something I'm trying to do. But look for just creative ways to add machine learning to things. And then use your advanced technical skills for fun. You know how to code. That has so much access. You can make robots. You can make ridiculous EEG things. You can make so many different tools in games and just applications. So don't be afraid to just step out and do something kind of silly. You never know where it'll end up. And also, Skynet is inevitable, but with EEG data, maybe we can make it more friendly and super custom to us. So, I hope that you enjoyed this talk, and I hope that you learned something and that the demo was cool. And again, if you want to keep up with me and how my air guitar project is going with all of this, follow me at Flipped Coding on Twitter. And don't forget that I use Conducto for all of my CI/CD pipelines now.
So first off, I just want to say that was a brilliant talk. I didn't even know this was an option for us to sit down and play with. So thank you for bringing it to my attention.
Yeah, I'm glad you guys liked it.
Yeah. What was your biggest? So this is one of the questions that I just want to ask. What was the biggest surprise you found in working with it? Was it that it was maybe easy to use, or
Honestly, I was surprised at how long it took me to figure out how to understand that data. Like,
okay?
it comes back just as numbers, so I figured maybe I could just, hey, those numbers are different, whatever. But no, that was the hardest part, was just getting the data in the right format.
Is it consistent enough? Really?
So when I first started that, I tried using like kind of a reset for, I guess, getting in the right mindset for thinking about like up or down, left or right. So the whole time I was recording data, I was listening to white noise just so it blocks out pretty much everything around me. So it kind of acts like, I don't know, putting myself in a box.
Yeah.
That way you can just focus.
So the white noise, you think that made a difference?
Yeah, it helped me concentrate a lot faster.
Okay, good tip. Good tip. So we have had some questions come in, so we'll move on to everybody else's questions, not just mine. So Mikhail has said, when do you see this becoming mainstream?
Oh gosh, I wish it was now, but I'm not sure. Like the headset that I have is not the most accurate, and the ones that do better that don't require a brain implant, they're fairly expensive. So it'll probably be a while before it's mainstream just because of the hardware.
Okay. Is the hardware good enough, do you think, to go mainstream, or is it just that it's so costly to do it?
I think the current hardware is good enough to go mainstream. It's just really taking the time to understand neurology, which not everybody wants to learn neuroscience. So that's that's probably the biggest like thing that's holding it back.
Okay, and speaking of neurology, our next question is on the subject. Do you think neurology and JavaScript or other languages could be used to detect mood or other thoughts that could help with treating mental disorders?
Hmm. Probably it would
Yeah.
just take some time to figure out like what features you should train a model for to detect moods and I guess predict what they're going to do or maybe what they should do. So I don't want to get too like deep into people's brains.
No, you don't know what you're going to find in there, do you?
No, I don't want to know.
No. Do you recommend any specific hardware to start playing with? Like, where can people buy your headset, for example, when you're using?
So the one that I was using is from a vendor called OpenBCI, and they have some pretty affordable like EEG and EMG sensors. It even
Okay.
comes with the software.
Well, is it on a real disc or?
No, not that real. You can download it.
Sorry, whenever anybody says real software, I always think it comes on a floppy disk or a CD or something.
Yeah, I haven't seen
Um,
one of those in years.
no, it's the save icon. That's pretty much the only remnant of floppy disks left, I think. Somebody has said that they think it would be pretty cool to do drawing with your mind. Is that something that you've seen done?
I personally haven't, but I think that would be a really, really complex problem just
Mm.
because thoughts are hard enough to process when you're just thinking about one thing, but trying to figure out where a person is thinking on a continuous path, I'm not quite sure how that would work, but maybe some neurologists are out there that could help us.
Yeah, and some JavaScript coders to do the other part with you, I guess.
Yes.
So let's just see. I think we've answered all of the question that's come in. So what I'm going to do is I'm going to wrap up here, but I'm going to, if assuming that you are sticking around, I'm going to suggest people come and find you on the table and really dive into this. And that might well be me because I've got lots of questions about this. So I want to say a huge thank you for taking the time to put that demo together and to record the video. And where, just if you could remind everyone, where can they find you online?
Usually you can find me on Twitter at Flipped Coding. So I post about the air guitar project from time to time if you want to keep up with that.
Oh, I'm sure lots of people definitely do. Flipped coding. Excellent. So thank you very much for your time. Everyone else, we will see you back here for another Q&A in, I don't know how long, but quite soon. Yes. So, Mika, thank you very much for your time. That was brilliant.
Thank you.